chi-square goodness of fit test in SPSS method 2. The test is performed when there is one ordinal data or variable and one nominal variable. The nominal variable or categorical variable can be dichotomous, that have two levels in it, male, females, yes or no, or it can have multiple levels in it, such as professions, doctor, dentist, scientist, and pharmacist. The test will examine whether there is a difference between the observed frequencies or count compared to expected frequencies, whether there is equal proportion or unequal proportion. Here in this data view in SPSS, I have a categorical nominal variable that have 4 levels in it. There are 200 cases in this variable. Click on variable view, and on the value as shown here, there are 4 levels for this categorical variable. Doctors is given number 1, 2 for secretary, 3 for pharmacist, and 4 for nurses. To determine whether there is a difference between the expected frequencies and observed frequencies, then chi-square test, goodness of fit test, will be performed. Before performing the test, let us look at the bar chart and the frequencies or count for each level within this variable. To do that, click on graphs, click on chart builder, click on OK, and then select the bar chart, drag it to the area here, select the professions, drag it to the x-axis, click on OK. A bar chart is produced showing the 4 levels within this variable profession and the count, which shows that the nurse have the highest count or frequencies and the doctor have the lowest frequencies. To perform the chi-square test, click on Analyze, scroll down to Non-Parametric Test, click on One Sample, and in this new window for One Sample Non-Parametric Test, select Customize Analysis, then click on Fields, reset this, then move the profession to the test fields, click on Setting, and in the Setting section, click on Customize Test and tick on the box for Compare Observed Probability to Hypothesized chi-square test. And for this icon for options, click on it, and in the new window here have options to choose from, whether to set the hypothesis that all categories have equal probabilities or to customize the expected probabilities. For now, we just leave that for as all categories have equal probability. Click on OK, click on Run. Few tables and graphs are generated. The first tables shows the hypothesis test. The null hypothesis states that categories of professions occur with equal probabilities. Since we have 200 cases, there should be 50 cases in each level or categories, and the test is one sample chi-square test, and the p-value is less than 0.002. The second table shows the test statistic value, which is 14.7, and the degree of freedom, which equals to n minus 1, which n is 4 levels, minus 1 equals to 3, and the p-value, which is less than 0.05. So this test shows that there is a difference between the observed frequencies and the expected frequencies. Looking at the bar chart here, it shows that the expected frequencies all have equal proportions or equal probabilities, as the frequencies for each is 50. And the other bar chart shows the count for each categories within this variable. Going back again to the window for the test and clicking on options icon and select the customize expected probability. Let's set that the probability for the first level is 10%, the second is 20, the third is 30, and the fourth is 40. Click on the space here, enter 1, and then 10 for 10%, for the second level 20%, and for the third 30%, and for the fourth 40%. Click on OK, then click on run. What will happen here is that the test will compare the observed frequencies with the expected frequencies that are set at specific probability or certain proportions as we have entered or inserted. Shown here from the hypothesis test, the categories of profession occurs with specific probabilities, 10% to 40%. And the significant level is less than 0.05, so the p-value here is less than 0.05, and there is a significant differences between the observed and expected frequencies, and the test statistics here is given as a value of 221.3. So this bar chart shows that the expected frequencies occurs at specified proportions, 10%, 20, 30, and 40%. 10% is equal to 20, as shown here, and 20% is equal to 40, and 30% is equal to 60, and 40% is equal to 80. So this is the way to perform chi-square goodness of fit test in SPSS.